Greetings everyone and welcome back to the shop. It has been a little bit of time since we have been here last. The last couple videos I have uploaded have focused primarily on fire alarm equipment. That's because I wanted to kind of share some of the recent stuff that I was doing in regards to that equipment. But today we have an electronics video. Specifically we're going to be talking about this multimeter here. So let's get right into it. This is an Owon brand B35T Plus multimeter. Now this is a true RMS auto-ranging digital multimeter, and it has a really interesting Bluetooth capability. This is a Bluetooth data logging multimeter. This can wirelessly data log readings over Bluetooth to an Android or an iOS device. Now that is pretty nice. Now this meter, of course, it's not a fluke. You're not going to be using this in high energy applications, but this is a great meter for hobbyist use and for light mains usage, I would say, because I have used this on the mains just fine. 120, 240 volts. This meter, it's built pretty well. It's pretty nice. It's about $70 or so on Amazon, maybe a little less, 60, something like that. So it's a mid-range meter. It does not have a removable holster. It has this nice blue, kind of a rubberized finish on it. It's built into the meter. It has a threaded screw for the battery terminals underneath the stand here, or battery cover, so it's threaded, which is nice because you're going to be opening that. This takes two AA batteries, which is nice for high current and long life. It has a nice backlit display that's easy to see. And I have a couple things set up here just to give a little bit of demonstration of this meter. I have my phone here to demonstrate the Bluetooth. I have a small DC motor to demonstrate the data logging. We're going to be turning this to generate a DC pulse, and I'm going to show the graph on the phone. We'll get to that later. I have a capacitor here because this meter does have capacitance measurement capability, and I have an 8K resistor to demonstrate resistance. I got the circuit board here that came out of an old or a fairly modern fire alarm panel actually that was scrapped because it had a defective main board. There's a couple diodes on here I can use to demonstrate the diode function. And then I have this old, new old stock Sencor Handy 36 capacitance and resistance substitution box. I just have to demonstrate a couple resistances. Now keep in mind when we use this box is old, so the resistors inside have drifted in value. I'm basically just using it just to show the meter's ranging capability with the resistances. And then I have another meter over here that we're going to be using just to compare against for accuracy. So first thing I'm going to demonstrate, or show rather, this nice case that it comes in. It says Owon on the front. And this is the case the meter comes in. This does have temperature measurement capability, so it has a thermocouple and some alligator clip leads that can go onto the end of the probes. We have a quick start guide and a little spec sheet and some probe covers and a couple other things in there. So that's very nice. You can take this with you really easily. It's got a nice handle on it. So let's get started. So these are the probes that it comes with. They're pretty nice probes. The leads on them, they're not silicone leads, but they're very flexible. They're nice. They have these probe guards on them that I'm going to take off so that it will be easier for us to do some measurements. Okay, and I'm going to turn the meter on, and we're going to start with DC volts. So as you can see, the digits are nice and big and easy to see. Let me just make sure, and if you zero it out, that's going to go to 0. Let me just make sure you can see that screen on the camera. Yep, you can see it just fine. So we're going to start out with a DC voltage measurement from my power supply here. This is a DC regulated power supply. Unloaded, it puts out about 13 volts. But we're going to go ahead and verify that real quick with the other meter. So we'll get this meter in here so we can see the voltage. 13.8 volts. So we should see about 13.8 volts on the Owon meter. $13.7, not bad. I trust this meter more than I trust the other one because this is a nice meter. It's probably more accurate than that other meter because that other meter is a little bit older. So it's pretty good on DC. We'll go ahead and we'll move on to the resistance measurement. So this has resistance, diode check, audible continuity, which is latching, and capacitance all on one range, or one selection. So this should be an 8K resistor. There we go, 8K. So you see that was pretty quick to read that. And now we'll demonstrate diode check. I'm sorry, not range, I want... There we go, diode check. So we just got a couple surface mount diodes here in the circuit board. We'll go ahead and check a couple. We should see about 0.4, 0.5 volt drop. And there we go, 0.5. That was nice and fast. Check this one. If I get a good contact on that, that one might be... You know, I think that's across an inductor, so that one's not going to read good. In circuit. There we go, 0.5 on that one. Alright, so diode check is nice and fast and responsive. Let's go to capacitance. Let's first demonstrate continuity, so latching continuity. It's pretty fast and responsive. We will move on to capacitance check. So here I have a 100 microfarad electrolytic capacitor. I'm going to go ahead and check it. Now capacitors usually take a minute or so to measure. So we're just going to connect it across here and we'll see how long it takes to read that. It should come up somewhere around 100 microfarads. Let's see here, get a good contact. Takes a minute. I know this meter is very good at capacitance. I've already tested it before. Alright, there we go, 1,167. Now did I say 100? I meant to say 1,000. This is 1,000 microfarads. So it read right in spec. Alright, so now we're going to move on to doing some more resistance measurements with the handy 36 capacitance box, resistance capacitance box. I'm going to go ahead and connect the meter up to it, and I'll just kind of read on the screen, or I'll read to you what it says here that it should read, and we'll check accuracy. Now keep in mind again, this box, I do not expect it to be very accurate because it's pretty old and the switches are a little bit flaky on it. I might even have a bad wire here. Eventually I'm going to redo this, but I'm just kind of going to see if we can get it going enough for us here. Alright, so that's supposed to be 10 ohms. It's reading 24. Once again, this is not an accuracy test. This is just to demonstrate ranging between ranges here. So I'm going to take it up a bit. As you can see, we're ranging nicely there. We're going up. Still pretty low ohms right now. It's 2K, 0.8, 0.9, 5.5. So now I'm going to switch it to times 1,000, so we're going to get pretty big values this time. It's about 5 meg. 2 meg. Open, like I said, this box is understored, so 350K, 190K, 100K, 58K, 37K, 20K, 10K, and so on. So that works. The resistance is very fast and very accurate on this meter. And now I'm going to demonstrate the data logging, which is the part that I'm sure you've been interested in. So this has an iOS app. It's free from the App Store. Now to turn on the data logging on this meter, first of all you have to hold down the backlight button to enable Bluetooth. Or I'm sorry, it's actually the relative button. But first I'm going to demonstrate the backlight. So this meter has a backlight, as you can see. It's nice and bright, and it allows for easy reading of the characters. Now we're going to hold down the relative button. So now you notice there's a Bluetooth symbol that came up here on the top. That means that Bluetooth is now enabled on the meter. So what we do is we get our phone here and we open the app and we go to our device. There it is, B35T. And there's now it's connected. So as you can see, the readings mimic what we see on the meter. Now let me see if you can see both the phone and the meter on the camera. Hopefully you can see the phone here. Let me, maybe I can prop it up on something. need something to prop the phone up on so you can see the reading here. Let's get this box. Come on, there we go. Can you see that? Let me move the camera over a little bit. Hopefully, I'm hoping the camera will be able to see that. Try turning on the backlight. There we go. So you can see that. So you can see it's pretty responsive. If I zero this out, you'll see them both go down there. One handy use for this would be measuring temperature. So now let's do the experiment I actually wanted to demonstrate. I'm going to hook up some different leads to this. I need some grabbing leads. So let me grab those really quick here from I got a bunch of test leads I keep up here. See, these are the ones that have the ends on them that I can connect to this little motor. I'm just going to use that to demonstrate the graphing function. So I'm going to go ahead and connect the meter to my motor here, just so we can get a DC signal. So if my leads don't fall off, you can see when I spin the motor, you see the voltage go up there. 1.5 volts. So I'm going to go here, we're going to do some graphing. So this is a really handy feature. You can see that the graph, there's a graph on here, and you can save the data. We can zoom in so I don't drop the phone. See, we can change the scale. Let me just take a look at this. There we go. So you can see the graph there, hopefully. Turn the backlight back on the meter. Now I'm hoping you'll be able to see that graph on the screen. I think you can. Hopefully you'll be able to see both the meter and the graph. Alright, so I am on DC volts now. So I'm going to go ahead and start spinning this meter, and you'll see it start to graph the reading. If my leads don't pop off here, let's go ahead and try this again. Now this should be graphing. Maybe I changed a setting. Let me open the app back up and reconnect to the meter. There it is. There we go. So now it's graphing. My leads are popping off the motor. I'm sorry, I'm just trying to do this without everything falling apart here. Alright, so let's go ahead and start bringing the voltage up a little bit, and you can see it starting to graph it. That's pretty cool, isn't it? So this will do real-time data logging. Turn the light back on. So that's pretty cool. Like if we had a temperature that we were trying to graph, that would be pretty handy. Or if we had, let's say you were measuring something like an O2 sensor in a car and you wanted to measure a value over time, that would be very handy. Let's go ahead and zoom right into the phone here. I'm hoping the camera will be able to focus on the phone screen. Yeah, I think you can see that. I'm just trying to get the best way for you to be able to see that. So that's pretty cool. So you see we go to resistance and it will graph that too. See, it's on 0 right now, and then we go to 0. You see it changing on the meter there. Let's go ahead and hook up a resistor. So you can see that's graphing it, and it changes the scale to be resistance instead of voltage like it should. And one thing I will actually demonstrate is we'll try temperature out. So I'm going to grab my thermocouple and we'll connect that, and we'll demonstrate graph and temperature, because that I think is a very, very useful feature to have. There's almost unlimited uses for that if you want to check how hot something was running or how long it took for something to get up to a certain temperature. We can do that. So, thermocouple on this meter, it just plugs into the temp jack. So, let's go to Fahrenheit. So it's showing about 70 degrees in here, so that's pretty accurate. And as you can see, it's in Fahrenheit here, from 0 to 200. So if I hold the probe in my fingers here, we can see we can change the temperature. Get that going up a little bit there. There we go, 80 degrees. I'm just heating up the probe. You can see it, see the graph going up there. We're at 85 right now. We'll take it back down. And you can see the graph changing to reflect the variation in temperature. Going down. As you can see, the graph going down. Now we'll go back up. So you can see it's pretty responsive. Now what I will do real quick actually is we will hook up my soldering iron so that we can really heat this thing up to show a big variation in temperature. So we'll get my soldering iron heating up here. I use this really trusty old Weller soldering station. Very nice. So I'm going to demonstrate that now with the graphing of temperature. So I'm just going to heat up the iron and then we'll put the... That should be hot enough. I don't want to heat it up too much because I'm not using it right now. I'd have to clean the tip off. But let's just touch the probe to the tip and we'll watch the temperature go up. Say 300. Let it cool back down. And you can see the graph there changing. Now the graph's falling back down. You can see it got right up to where it was at 200. Put it back on there. 290, 300, there's 300, and see it's starting to drop down as the iron cools back off. So you can see it get back down to ambient temperature. Unplug my iron because I don't need it on right now. Just going to make sure that you're able to see that. There, so it's basically cooled back down and you can see how our temperature spiked and went up and down. Let's get this a bit closer so you can hopefully see it. You can see our graph there as we're in temperature right now. For example, if I switch the meter to voltage, unhook our temperature probe. So you see when we go in voltage, you can see that our graph goes back to voltage. And we go back here, of course, you can actually see the display. So that would be handy if you're working on a car or something and you can't directly observe the meter screen. You can take your phone with you and you'll be able to see the readings. So yeah, I just wanted to show you that. Let me zoom back out here. Alright, and we'll turn off Bluetooth. Now to turn off Bluetooth, we just hold the relative button again, and then it went back to Bluetooth symbol disappeared, so that means the Bluetooth went off and the phone disconnected. But yeah, you can save those readings in the app there. When you have a graph open, you just click on save and it will go ahead and save those results. But yeah, that was just a quick video on this Owon B35T. I think it's a great multimeter if you're an electronics hobbyist, if you need a meter, if you're in the automotive field and you just want to have an inexpensive, relatively inexpensive meter around to be able to play around with some data logging and graph some temperatures and some voltages. And I think it's a very nice meter. I think it's well built, it feels solid, it's rugged, it's not too heavy or not too light. The screen is nice and big and easy to see. It's got a nice backlight. I think it's a great meter for those purposes, and I would highly recommend it to anyone who wants an inexpensive data logging multimeter. I don't think it's compatible with PC, unfortunately. I think it's just compatible with Android and iOS, but you can of course export the data logged file to a computer and save it that way. So that's about it for this video. I hope you found this useful, and if you're in the market for one of these meters, I would highly recommend you pick one up. You can get a pretty good deal on these, and I think they're a great value for what they are, and they are very nice to have around in the shop. So thank you guys very much for watching, and stay tuned for more electronics and fire alarm related videos to come in the future. And have a great day, everybody. Take care.